Hello, this is Syed Rajanul Haq Nabil, team leader, Crux open source ventilator team. Today, I am going to show you the basic operation of our open source turbine based low cost and extremely power efficient ventilator. So first, I will here you can see the test lung, the flow sensor. Here is a pressure sensor probe. Pressure sensor probe connected here. This is the PEEP valve. This is the connector port of flow sensor. This is the reset button if needed for test purpose. And here you can see our main screen. And as you can see, this ventilator now not connected with any external power source, so it will run completely from the battery. So here is the app Crux Open Ventilator. I will click now. So first, show paired device. I'll click here. Then I have to connect the ventilator Bluetooth being connected. So we have to wait while it connecting. Meanwhile, the test lung is Draeger test lung. This is very high quality and professional grade test lung. And here is the patient circuit that is connected with the ventilator. And this is the one-way valve, and this is the PEEP valve. Oh, by the way, I have to on the power supply, otherwise it will not connect. Okay, so now I will click. Okay, now here you can see the BPM, inspiratory time, PEEP, tidal volume, and here is the mode. Here is the actually pressure control ventilation or PSB, pressure support ventilation, PRBC, and other modes. But for now, PCB and PRBC is working. This mode is should call PCB, not PSB. We will edit this. So now if I start now it is in a PRBC mode. If I on the ventilator, I should show the how I can change the BPM and TI value. For example, if I change here, and we can change the TI value, which is inspiratory time. Then if I click update, I'll keep it in 6. Okay, if I update, and here is the tidal volume, I can change to 200, and PEEP maybe lower. Okay, so now if I start the ventilator, I have to click on. So initial data is being initialized, and now ventilator will start ventilation. And now here is you can see the various alarm. Okay, so for now I will snooze all. From settings, here I can snooze everything. And here you can see the debug data that is being transferred from the internal Arduino Mega. Here you can see the ventilator is ventilating very very well, and very nice curve. Here is the flow, here is the tidal volume, and here is the actually the pressure. And here is the PEEP, here is the PIP, PEEP, actual tidal volume. Here is the given tidal volume, and here is various other things. Here you can see the alarm has begun. If we want to change the alarm, then here we can change the alarm parameter. Very easy user manual. Now I will show you the ventilator. Now ventilator will ventilate while I will connect the main power supply rather than the internal battery. I will disconnect the battery connection, and I will run this ventilator completely from this power supply, and I will show you the power. Actually, I opened the whole ventilator so that you can see the internal circuitry and mechanical things. And now we are running as previous parameters, but here you can see the power supply, power consumption. So here you can see this is extremely power efficient ventilator. And by the way, I completely removed the battery connection so that the entire power is being transferred from this power supply. And here I have attached a power monitor so that we can see the power consumption. Here you can see this is extremely power efficient. And now here you can see the pressure release mechanism here, and then this is the Arduino Mega. Beneath of this Arduino Mega there is a turbine, and this is the circuitry, and here is another power supply. If we want to apply 220 volt directly here, we can apply, and this power supply will transfer the power. But for now, for testing purpose, we are transferring power from this portable power unit, and here we are monitoring the entire power. So and here you can see this is our own PEEP valve. This is working really good and very cost efficient. Maybe we can make this PEEP bulb under $1, and here you can see the one-way valve. If I remove the ventilator will detect the disconnection immediately. Here is actually the one-way valve. So, and ventilator actually detect the disconnection, and now if I connect again, it will detect that I have connected here. So there are lots of alarm going on because I have disconnected the entire ventilator circuitry, patient circuit. So this is our Crux open source ventilator, and I think it will be useful for researchers, patient, doctors, and for everyone. Thank you very much.